Hello children, welcome to my channel. So let's start with today's class. Today's topic is homologous series. So children, what do you all understand by this word homologous? So you will come across many words, such big words in chemistry like homologous. So nothing to get confused. Just understand the meaning of the word. It's not only pertaining to chemistry, but just understand the meaning of this English word homologous. So whenever there's this word homologous, when homo is attached to it, it means it's similar, something of the same kind. The meaning is similar kind. So homologous series is nothing but having the series of the same kind. So now we are aware that carbon atoms, they come together, they link up together to form larger molecules and to form compounds. So when they link together, like I explained in my previous explanations, they link up together and also with hydrogen atoms coming together and they form big compounds. Small, medium-sized and big-sized compounds. So when they form compounds, for example, propane, so 3 carbon atoms in propane are linked up with 6 hydrogen atoms, and that's how the number keeps increasing from small carbon compounds like methane, the simplest carbon compound. The carbon atoms keep adding, the number increases, and that is how long chain compounds are formed. So if it has a functional group, like I explained in my previous classes, it will link up with either a halogen or oxygen, like ketone, aldehyde, carboxylic acid, chlorine, bromine, all such functional groups. So suppose it links up with chlorine, then the properties of this compound will completely depend on this functional group chlorine. So irrespective of the size of the compound, it may be a small compound, it may be ethane, for example, 2 carbon atoms attached with a functional group. Now why it is called functional group? Because irrespective of the size, it may be consisting of 5 carbon atoms, 6 carbon atoms like hexane, but the properties remain the same. They remain similar because of the functional group being attached to it. So consider alcohol as the functional group, and we'll take example of methane. So it will be, so methane chemical formula is CH4, but when it is attached to alcohol, it is replaced with a hydrogen atom. This is attached, alcohol group OH. So it's methanol. Then same thing happens with ethanol. So this is methanol, this is ethanol, and then comes propanol. So it keeps on adding larger chain compounds, but there is something similar in all of these compounds, which is the functional group attached, which is nothing but the alcohol functional group. So it's methanol, ethanol, propanol, butanol. And in all this, the functional group defines the properties of the carbon compound, irrespective of the size of the compound. Now when these keep on increasing. So obviously when the size increases from small compound to medium size and to big carbon compounds, the molecular mass definitely will increase because of the size from small to big. Small carbon compounds will have less light molecular mass, and when it increases larger size, the molecular mass is more. So definitely there will be gradation in the physical properties, like in the melting and the boiling point. Correct, because of the molecular mass increasing. So there is gradation. Gradation is nothing but changes, slight changes, differences. It is similar, it is in the form of a sequence. So a small compound will have definitely the melting and the boiling point to a lesser value, as in comparison with a larger sized carbon compound, which will have greater value of melting and boiling point. So also the solubility, it's a physical property, so that also will be affected. There is gradation that we seen right from small compound to large compound, changes in a sequence which is observed, and also changes in the solubility. But remember that the chemical properties remain the same irrespective of the size of the compound, because the functional group is the same. So just remember these key important points. Now consider this small carbon compound methane. Next is ethane. Next is propane. After that, butane. And then pentane. So look carefully, nothing complicated, nothing to be memorized, just basic understanding. Just observe this carefully. You will observe that the difference between the first and second, second and third, third and fourth, fourth and fifth is same. So just observe the difference in carbon atoms with methane with respect to ethane is 1 carbon atom, and here the difference is 2. So you will observe this, right? And with respect to ethane and propane, the same difference. So here there are 2 carbon atoms, whereas here there are 3 carbon atoms. So 1 extra carbon atom, here 2 hydrogen atoms. Same thing, similar thing happens here. See, 1 extra, here 8, here there is 10. So 2 extra hydrogen atoms. Same thing happens here. Just make your observations, nothing to memorize, just basic logic and basic understanding. So if you observe carefully, you will notice that the difference between methane and ethane, ethane and propane, and so on is the same. There is 1 carbon atom and 2 hydrogen atoms, keeps increasing. So now we'll check for unsaturated carbon compounds. We'll start with ethene. Next is propene, and so on. So by observing this, we can write a generalized formula which is nothing but CnH2n, where n is a number 2, 3, 4, 5, 6, 7 and so on. So CnH2n. So if it is 2 carbon atoms, then it is 2H2 and put the same number 2. So it's C2H4. So this is the formula for unsaturated double bonded compounds. Now we'll write the similar one for saturated carbon compound, which is nothing but CnH2n plus 2. And for unsaturated triple bond, it's nothing but CnH2n minus 2. So by observing the series right from methane, ethane, propane, and in double bonded ethene, propene, all this, by observing it, you will get this general formula. So when it is saturated, it is alkanes, unsaturated double bond, alkenes, and unsaturated triple bond is alkynes. So children, let me just repeat. Homologous series, nothing to get confused about. Just understand the word homologous is nothing but similar, of the same kind, homologous. So it has the carbon compounds from small to large carbon compounds, which is attached to a functional group, which I explained, like alcohol. It can be a ketone, it can be aldehyde, it can be chlorine, bromine, it can be carboxylic acid, and the properties of it is completely depend on the functional group attached to it. So the chemical properties are similar, they don't change irrespective of the size of the carbon compound, even if it is small or it is big. But the physical properties do show a gradation, a slight change, a slight variation in a sequential order, similar change, and that could be noticed with the melting and the boiling point. Definitely if the molecular mass increases, there would be change in the melting and the boiling point. Also another physical property, which is solubility. So the solubility also, there is change in it. So now let us discuss another topic. So children, do you all know my name? Well, my name is Sephra, and just like how I have a name, you all also have names. You all have different names, and so also our chemical friends also have different names. Our carbon compounds also are given names, just like you and me. They should be addressed and differentiated respectively with their names. So now let us study the nomenclature of carbon compounds. So nomenclature is nothing but naming them, just to differentiate each of these carbon compounds, just like how you and me have names, we have beautiful names, so also they have nice good names to understand them. So firstly, to begin with, to name them, just count the number of carbon atoms that they have. So the first step is count the number of carbon atoms. Like methane, 1 carbon atom, ethane, 2 carbon atoms, propane, 3 carbon atoms, butane, 4 carbon atoms, pentane, 5 carbon atoms, and so on. So it all depends on the number of carbon atoms present in them. Secondly, if it is saturated, unsaturated, so in saturated is single bonds, and unsaturated either there is double bond or triple bond. Then it would have an suffix to it, like something like this, So in saturated, it's alkane, Kane, which is saturated. For unsaturated, double bond, it is alkene. So don't get confused, just read the word carefully. When it is ane, alkane, it is saturated carbon compound. When it has ene, alkene, it is unsaturated double bond. And alkyne, you just need to see the second part of the word. When it is alkyne, then it is triple bond, unsaturated. So that would be the step 2. And step 3 is when it has a functional group, like I discussed in my previous class. Either it could be a halogen, bromine, chlorine, it could be alcohol, it could be ketone, it could be aldehyde, it could be carboxylic acid, anything of that, it is attached with either a suffix or a prefix. So prefix is nothing but prefix it. So attaching, fixing means attaching, and pre is nothing but before. So don't get confused, just split the word and understand. Prefix, pre is nothing but before and fix is nothing but attaching it. So suffix is after the word. So prefix example I can give like chloromethane. So the functional group chlorine, which is attached before, which is attached as a prefix, which is chloromethane, and suffix is attached after the word, like methanol, so it's methane, and alcohol, the functional group, so it's methanol. Example, methanol. So methanol. So methane having the functional group alcohol is nothing but methanol. So in this example, the functional group, which is alcohol, is as a suffix given to its name. And prefix, you can say chloromethane. So here it is as a prefix, before the word, before the compound methane, so it's chloromethane, and here it is as a suffix, which is methanol, alcohol attached to methane, methanol. So now I will just state some examples, so you will get a thorough understanding of the naming of these carbon compounds. So let's have a look on some examples. So the functional group, if it is a halogen, it's either chlorine or bromine. So it would be a prefix, before, fix, attach, prefix before the word, chloro or bromo. See this example here. First step I told you all, count the number of carbon atoms. So don't hurry, don't get confused, just with practice you will get this, you will understand and you will remember. So stepwise, the first step is count the number of carbon atoms. So in this example it is 3 carbon atoms, so it is propane, ane, because it is saturated, single bond. So prop, 3 carbon atoms, ane, because it is saturated, single bonds are present, and the suffix is chloro, a functional group. You can see here there is no hydrogen, it's a functional group is attached. So prefix, prefix it before the word propane, prop, 3 carbon atoms, ane is saturated, alkane, alkyne, alkenes, remember? So propane, prefix it, chloro, it's chloropropane. So as you practice, go through several examples, then you will remember this. Not required to memorize, just understand the procedure stepwise. So second example, we'll have a look. Alcohol. Alcohol as a suffix OL. So don't get confused again, read the word very carefully. Here when it is aldehyde, it is AL. When it is alcohol, it is OL. When it is again ketone, it is ONE. So don't get confused. Here it is as a suffix. Again count the number of carbon atoms. 3 carbon atoms. So prop. Single chain ANE. So propane. Here it is as a suffix after the word, not prefix, suffix. So it's propanol. OL attached. So it is actually propane. Propane, just remove this E letter from it. So it is, I will eliminate this last letter from it. So it's propan plus alcohol OL attached to it. So it's nothing but propanol. So it's so simple. So next example, aldehyde, suffix Al attached to it, 3 carbon atoms, prop, single bond ane. So propane, it's as a suffix where Al is attached. So the same thing, it's propane, letter E, remove it, eliminate it. So it's propan plus Al. Again I repeat, don't get confused. When it's aldehyde, it's Al. When it is alcohol, it is OL. So read carefully, propanol. So that's how you get the word. Let's have a look at some more examples. You all will get in-depth understanding. Let's have a look at some more examples. The functional group ketone attached as a suffix. Firstly, start counting the number of carbon atoms, which is 3. So it's propane, it's single bond, saturated carbon compound. So it's ANE, propane. And eliminate the E letter out from propane. So it becomes propan and attached with ONE because it's ketone, the last letters. ONE, so it's nothing but propanon. Next is carboxylic acid attached as a suffix oic acid. So 3 carbon atoms, propane. So eliminate the letter E, it's nothing but propanoic acid. So when you look at these names for the first time, it seems to be confusing. It sounds little difficult, but nothing to get confused. If you understand the meaning behind it, if you do it stepwise, then definitely you will be able to name it. So keep practicing, go through several examples, and that's how you will understand how it needs to be done. So third one is alkenes, double bond, it as a suffix ENE, so it's propene. So this is as a practice, keep repeating alkynes, suffix YNE, propine. So children, just carefully read the functional group and carefully name it, because when alcohol it's OL, when it's aldehyde it's AL, when it's alkenes it's ENE, when it's alkynes YNE, alkanes ANE. So just carefully read it, and definitely this will be very easy for you all to name it. So children, if you all have any doubts regarding my explanation, then do drop your comments down below in the comment section, and I'll definitely try to reply to you all at the earliest. So subscribe to my channel, stay updated for my next video to come up, for my next explanation. So I'll see you all in my next video.